All right, before we look at the graph, let me talk about the in algebra one. Back in algebra one, you guys learned the slope-intercept form, and as a matter of fact, your algebra teacher should have called it y equals mx plus b. Remember, they came in and said the m was representing the slope, and then the b represented the y-intercept, but they never told you exactly why m and b were chosen because slope has no m, y-intercept has no b. They just said m and b. But in reality, the reason why we chose m for slope, because it tells you how to move. The slope tells you how to move from one point to the other. The reason why we chose b for the y-intercept, because that's where you begin. That's when you begin when you graph a line. That's where the m and the b come from. So looking at here, looking at my y-axis, I'm crossing at a 4, so it makes sense that I begin at 4. From this point to point B, I go up 1 over 3, 1/3, my program estimated as 0.34. So like I said, I'm showing you guys going this equation before we look at our work. If I don't change the slope, the inclination of the line is the same. I keep on moving 1 over 3, but I do move the line up and down. It makes sense that my y-intercept changes because I'm crossing the y-axis at a different point, right? You guys can see that it happens. But if I come and say, no, I want to leave my y-intercept there close to 6, I'm just going to change the inclination. It makes sense that the number in front of the x is the one that changes. My program gives it to me in decimals, but we're going to deal with them in fractions because it's a little bit easier. So that's why we call this the slope-intercept form. But so now that we remember how to draw lines, let's take a look at question number 1. It says solve each system by graphing. What solving means is I want the x and the y value that make both of these statements true. Not just one, but both. Right? We could start guessing. I could come and say, well, a solution for the first equation, x equals 0, y is 1. That is a solution for the first one, but then it doesn't work for the next one. Right? If I plug it into the next one, it doesn't work. So then I can try another solution and another and another and another till I get tired, or I'm just going to do this by graphing. So the way we graph, let me minimize this. The way we graph, on the first equation, my y-intercept is positive 1. So on the y-axis, let me graph with the point 1. That's where you begin. Now the slope, the number in front of the x technically is a negative 1. But I would like it as a fraction, so that way I can easily make that a fraction, put a 1 at the bottom. What this thing says is go down 1 and 1 to the right. So from the point that I marked earlier, let me go down 1 and over 1. In fact, your algebra teacher even called it rise over run. You guys make a line that goes through those 2 points the best that you can. Probably your algebra teacher also mentioned that line, what it represents, it's all the solutions for the first equation. Any point on that line makes that statement true, the first one. Now, let me take a look at the second equation. I start at positive 4. So I'm there, positive 4. My slope is 2 over 1. All right, my slope is 2 over 1, which means go up to 1 to the right. But I don't have room to go up to, and I'm not going to guess where up to is. When we go off the picture, what we're going to do, we're going to change both of these signs, negative 2, negative 1. So go back and change both of them. Now this one says go down 2, 1 to the left. So from the red point, let me go down 2, 1 to the left. Let me connect my points. Now, my solution for the two equations is the point of intersection. My two lines cross at the value negative 1, positive 2. So that is my solution. Right? X negative 1, y positive 2 is the solution that will make both of my equations true. Right? You can plug it in if you don't believe me, but that's what it happens. Right, that was it. Let's take a look at number 2. Let me move to this other side. So For the first equation, I'm going to start at negative 4. In fact, let me put it right here. So the first equation, I'm going to start at negative 4. So I start there. My slope, it has a negative sign. I'm not going to give the negative sign to both top and bottom. I'm only going to give it to only one. Because I know in a fraction, in order for the fraction to be negative, the two signs are different. So I'm going to make the top one negative, the bottom one positive. So this one says go down 1, 3 to the right. So let me go down 1, 3 to the right. Let me make a line that goes through both of my points. Something that I recommend for a nice line is the edge of your ID. They work great. So that's the first equation. The second line, I'm going to start a positive 4. So it's positive 4. The slope is 7 over 3, but I have no room to go up 7. So I'm going to go back and change both of the signs. Negative 7, negative 3. So that means go down 7, 3 to the left. So let me go down 7, 3 to the left. I'm going to connect them. And once again, my solution, it's the point of intersection, which in this case is negative 3, negative 3. So draw the two lines, and your solution is the point of intersection. And those are the values of x and y that make both of the statements true. So any questions for the first 10? No? Which one? 4? Looking at 4, I'm going to start a positive 2 in the first equation. I'm going to start a positive 2. My slope says up 1, 2 to the right. So from the point, let me go up 1, 2 to the right. Let me make a line that goes through my 2 points. For the second equation, I'm going to start at negative 4. Remember, I came in and said the negative sign in front of a fraction, I'm either going to give it to the top or the bottom. If I give it to the top, it will mean go down 5, which I have no room to go down 5. So let me choose to give it to the bottom instead. So now this one says go up 5, 2 to the left. So from the point, let me go up 5, 2 to the left. My point of intersection is negative 2, 1. Okay. Any other questions for the first 10? Number 3. I know we have 3 on the screen there, but let me bring it to the right side. So the first equation, I'm going to start at positive 4. Technically, the number in front of the x is a 1. So 1x. But I want it as a fraction. So let me put another 1 at the bottom. So now my slope is 1 over 1. Up 1 over 1. So it gives me that. I'm going to draw my line. For the second equation, I start at negative 3. My negative sign in front of the fraction, let me give it to either the top or the bottom. Since I cannot go down 4, I'm going to give the negative to the bottom. So that thing says go up 4 and 3 to the left. So from this point, let me go up 4, 3 to the left. My point of intersection is negative 3, 1. Okay, I think the rest, for the first thing, you guys can finish the other 6. But let me take a look at number 11. I know number 11, you guys have it on your left of your paper. I have it on my right of my screen because of the reflection of the window. So I'm gonna leave number 11 there. You guys have room at the right of your paper, or the left on your paper. So the first thing we gotta do in order for us to graph it, it's nice when when the y is by itself. Notice how in the first hit, you notice question number 10 there, y is by itself and everything else comes after. For number 11, y is not by itself, so get it by itself. So looking at the first equation, let me move the x to the right. My goal to begin with is get the y by itself. So I have negative 4y is equal to negative x plus 16. Remember, every time you move something from one side to the other, switch the sign. Now divide everything by negative 4. You guys are going to get the y is equal to positive 1/4 x minus 4. I call it positive because negative divided by negative, it's positive. And then positive 16 divided by negative 4 is negative 4. So I start at the negative 4. My slope says go up 1 over 4. So up 1 over 4. Do the best on your line. Now on the second equation, the second line, let me move the 7x to the right. Remember, my goal is get the y by itself. So I have 4y is equal to a negative 7x plus 16. Divide everything by 4. So we're going to get y equals negative 7 over 4x plus 4. So I start at positive 4. I go down 7 over 4. I connect my points. And my point of intersection in this case is 4, negative 3. So the difference between 11 and the first 10 is that y was not by itself, so we have to get it by itself. Notice once again on the first equation, I move the x to the right, switch the sign, divide everything by negative 4, and then there's y by itself. On the second equation, I move the 7x to the right, change the sign, divide everything by 4, and there's y by itself. Any questions on the rest? 15? All right. Take a look at 15. Let me move the x to the right. So that looks like negative 2y is equal to negative 5x minus 6. Let me divide everything by negative 2. So that looks like y is equal to positive 5 over 2x plus 3. I can graph that one. Positive 3. Up 5 over 2. I have no room to go up 5. But when I have no room, I go back and change both of these signs. So now it says go down 5, 2 to the left. Go down 5, 2 to the left. Now for the second equation, move the x to the right. So you have y equals negative x minus 4. So I already have y by itself. I'm going to start at negative 4. My slope technically is negative 1. I want it as a fraction, so negative 1 over 1. So that means go down 1, 1 to the right. My point of intersection is negative 2, negative 2. So we're good in solving by graphing?